Okay, so this lesson is understanding large and small percents. So percent is always out of 100. There's 100 things. We always put it like, as if we write it as a fraction, we can write it out of 100. We can represent these percents by using a grid with 100 squares, and we can shade in the area that represents the percent we want to show. So, for example, we're going to represent each of these percents on the grid, the 100 grid, by filling in the number of squares represented by the percent. So 50% is going to be 50 out of 100. And that means I'm going to fill in 50 out of 100 of these squares. So I can cut this grid in half, and then I can fill in all the squares, all 50 of them, because I know there's 10 in each column and 10 in each row. So we can do this a couple of ways, but I'm just going to do it this way. So filling in 50 of the squares. Okay. 100% would be, of course, all of them. So I would fill in the entire grid. Every square in the grid would be colored in to show that that would be 100 out of 100, which is also the same as 1. Because if we divide by the same number, we just get 1. 5 out of 5 is 1. 100 out of 100 is 1. So I'm filling in 100 out of 100 squares. All of them. Okay, the next one, 72. So 72, again, represents 72 out of 100. So I have 100 squares here. I'm going to fill in 72 of them. As I said, there's 10 in each row. So that's 1. If I fill in 1, 2, 3, 4, 5, 6, 7 rows completely, all the way down to here, that means I will have filled in 70 squares. So how many more would I need to fill in to represent 72? Of course, just 2 more. So fill in all the 70 above, color them all in, and then I'm going to have to fill in 2 more at the bottom here. And then if you were looking at this and trying to figure out what is that percent, you could count the number of rows. You'd say, oh yeah, there's 7 rows, that's 70, oh, and then 2 more, so 72. Kind of going backwards. So we can also represent percents that are greater than 100%. So if something's less than 100% or 100% exactly, we can represent it easily. However, if we have something like this where it's bigger than 100%, then what I'm going to have to do is fill in all the squares in 2 full grids, because this is 210 out of 100. But I'm going to fill in more than there are. So I'm going to have to fill in 2 full grids and 10 more, because 2 full grids would represent 200. I'm just going to do this kind of quickly. So there's 2 full grids. All of them are filled in. Just use your imagination. And then on top of that, I'm going to have to fill in 10 more. So I'm going to fill in an entire row, which will represent 10 more on the grid. So that's 210%. We can also, though, represent percents that are smaller than 1%, that are smaller than 1%, which are very small, by using part of one grid square to show the fraction. This is called a fraction percent. A fraction percent. So we're going to look at these 3 examples here. First one, 0.5%. So I'm going to take one of these boxes and I'm going to fill it in just half. So what I usually do is I expand the box. Okay, sometimes to make it a little bigger, to make it a little easier to see. I can cut the box in 2, and then I fill in just 1/2 of it, so one side of the box. 0.3% is a little more complicated, but what does that equal? Okay, so 0.3 is like 0.3 out of 100, so that's like 3 out of like 0.3 is 3/10, so that's like the top would be 3/10 out of 100. If you were kind of thinking about this in terms of a fraction over a fraction, we don't usually do this, but I'm doing this to kind of illustrate how we fill in these boxes. So what I'm going to do is I'm going to take one box, I'm going to again expand that box, and I'm going to cut it into 10 pieces because we have 3, the top is 3 out of 10. So out of that one box, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And I'm going to cut that in half. Now I have 10 squares, and I'm going to fill in 3 of them. So 1, 2, 3. So 0.3%, because it's so small, but I have to take a box, I have to cut it into 10 pieces because I know 0.3 is 3/10. And I'm only going to fill in 3 out of 10 of those pieces of one box. So it's a very small percentage. Let's look at the next one, 12.1%. So sometimes you want to look at the decimal. What does that 0.1 mean? Well, it's 12 and 1/10%. So I guess I could have done that one over there too, 0.3%. So this one's 12 and 0.1%. So the same thing, I'm going to take one box. Actually, first of all, before I do that, I need to fill in 12 total. So because I have 12 holes, 12 whole pieces. So 12 whole squares, I'm going to fill in. So that's 10, 12. And then this box, I'm going to expand, just like I did in the last example, into 10 more blocks. So 1, 2, 3, 4, 5. Cut that in half. And this time I'm only filling in 1. So I have, and I guess you could kind of like fill in the box a little bit just to show that you're filling in a little bit of that box, and then to show kind of expanded above. So it's a good idea to take one of those boxes, expand them when we're dealing with small percents. Let's look at a couple problems involving percents. Okay, so Mr. Howell, it's me, completes a test, but stayed up way too late trying to cram the night before. His mark on the test is 13 out of 45. That's awful. Probably because I'm sick right now. So I probably stayed up too late because I was not feeling well, and then I took the test anyway. What is his percent? Okay. The easiest way to do this is just use a calculator. Because all we're going to do is we're going to take 13 out of 45, and every fraction question is actually a division question. So that's like 13 divided by 45. 13 divided by 45. And this is an easy question to do in your calculator. It's hard to tell the percent because the bottom is not 100. If the bottom is 100, then you can just say the percent right away. Oh, that would be 13%, but it's not 13% because it's not out of 100. It would have to be out of 100. And I could maybe try to get this out of 100. If this was 13 out of 50, it would actually be a lot easier to get a percent because I would just multiply both by 2 to make an equivalent fraction. But this time it's much more complicated. So in this sense, I'm just going to use my calculator. I'm going to convert this to a decimal. So I get 13 out of 45, which is 0.2. We're going to round to the nearest hundredth, so 0.29. Okay, and 0.29 as a percent, what I do to get a percent is I multiply that decimal by 100. So when I multiply by 100, I move the decimal place 2 places, and I end up with 29%, which is a fail. I failed this test because I stayed up too late. I was sick. I shouldn't have taken the test. Didn't know what I was doing. Okay, last example here. Johnny starts taking growth pills, to help him gain height for the basketball team. Clearly wants to play basketball. He grows from 180 centimeters to 198 centimeters over the summer. So we're going to have to answer this question by what percent did his height increase? So I'm going to break this into 2 steps here. The first, I'm going to subtract the 2 values. I'm going to take the height that he grew to, which is, that's a lot of height. You can't grow that fast. You'd be hurting. So I take 198, I subtract off 180, and that leaves me with, of course, 18. Now what I do to find the percent increase is I divide the increase, which is 18, by the original height, which was 180. So I take 18, I divide by 180, and again, I'm just going to use my calculator because it's kind of an easy thing to do. Out of 180 is 0.1. Okay, and 0.1, so this would be a 10% increase. I know that because to convert that to a percent, of course, we multiply by 100 again. So we move it 1, 2. I'd have to add a 0. So that would be 10% increase. But in terms of his original height, if we're comparing to the new height to his original height, because it's a 10% increase, I take 100% and I add on the 10%, so I get 110%. So his new height is actually 110% of his original height because it's an increase, it's getting bigger, so it has to be more than 100%. So that's how we do percent increase. Hopefully that makes sense, this lesson. Go back to the beginning if you need to watch it again, or Let me know if you have any questions.